When programming games, it's natural to think that your goal is to write code, because obviously, right? Well, as I've programmed more and more, I've realized something about myself. In the words of Jack Dieterich,
"This is what I tell the guys at work all the time. I hate code and I want as little of it as possible in our product."
Code is great and all, but with code comes bugs, readability issues, and everything we hate when programming. Unfortunately, if we want our game to work, writing code is a necessary evil. When programming games, your number one goal is to write code that works, no matter how good or bad it is. When you're just starting out, that's hard enough. No need to push yourself any further. But once you get to a point where you can reliably write code that works, your next priority is to make your code easy to read and easy to modify, whether by other team members or your future self. Because although your number one priority is to make sure the code works today, your number two priority is to make sure it works tomorrow, and the next day, and all the days after that. As for myself, I've written some good code, and lots of very bad code, often in the same project, and I've learned plenty of lessons from it. So whether you consider yourself a programmer or not, I want to offer some of my tips for programming games in a readable and maintainable way. And before we start, these aren't specific to any one language or engine, although I might use some specific examples. And if you have your own tips, let me know in the comments. The first tip is pretty fundamental. For those not familiar, state is the collection of all the variables that can change throughout your game. For example, in a platformer, state might consist of the player's position and velocity, as well as the current level and the position of any enemies. There's also a lot of state behind the scenes: the global timer, the player's animation, whether the game is paused, settings, etc. At the most basic level, games, and computer programs in general, are about changing this state based on inputs from the player, then using it to generate an output. Luckily, game engines handle some of this state for us. The scene tree in Unity, Godot, and other engines keeps track of what objects exist in the game world, as well as their position, rotation, and scale. But as programmers, we usually need to add our own state through scripts. For example, if you add a health variable to your player script, you're adding state to your game. All good so far. The danger comes when you keep track of state in two or more places. For example, say you have a health variable in your player script, as well as a health bar in your heads-up display that both need to be updated. How do you keep them both in sync? You have a few options here. You could keep them separate and just hope that the UI gets updated wherever you change the player's health. This is pretty obviously bad, but it's the kind of mistake that can trip up newer developers. Of course, you'll learn quickly when someone forgets to update the UI after changing the player's health, especially when the player dies seemingly out of nowhere while your health bar is still at 50%. So instead, you could add some code in the player script that runs each frame and constantly updates the health bar UI to match the player's health. This is a lot better, and it's ideal in situations where updating the UI multiple times per frame would cause slowdown. However, I'd argue that it's still not the best solution, because the health state and the UI state are still decoupled. If some code updates the health bar without updating the player's health, it'll mysteriously, or perhaps frustratingly, do absolutely nothing. To me, the best solution is to encapsulate both the health variable and the UI. That is, don't allow other scripts to access them directly, but create a function that changes them both. This seems like a complex solution, but in a lot of situations it's the best approach. Now there's no risk of changing one state without changing the other. And when you go to add polish, like for example a sound effect whenever the player heals or gets damaged, you know exactly where to go. Be aware though that this approach also requires you to document your code. If someone else or your future self comes along and wants to change the player's health, they need to know what function to call. This is admittedly a simple example, and it probably seems academic, but as your state grows more and more complicated, situations like this will occur more often. Applying this philosophy consistently can make your game very resistant to bugs. If you watched my recent videos on Tetris City, you'll know that I was very conscious about planning the game, and that includes state management. Because of this, there were very few programming bugs in the game, even with several programmers working on it. On the other hand, while developing Breezy, I had almost no regard for state, and it took a long time to iron out all the bugs that resulted, even though I was the only one to ever touch the game's code. Game engines, believe it or not, are made by game developers to help you make games. For any problem you might encounter while working on a game, it's likely that the engine developers have thought about that problem and provided a solution, especially with open source engines. But any mature engine will have all sorts of built-in functions and systems for things that might be time-consuming to program on your own. Of course, when you're just starting out with a new engine, you'll only know the basics, which is fine. It's daunting to learn all these new tools, and when you're prototyping a game or exploring a new engine, my advice is to start out with whatever's most comfortable and familiar. But when the time comes to write real code, the best option might be something new to you. Here's an example. When learning Unity, one of the systems you learn early on is player prefs, which lets you write settings and basic metadata values to your computer's registry. These values save across sessions but are generally specific to your computer, which makes them useful for things like display settings. But in a pinch, you can also use player prefs to save other things, like a high score for an arcade-style game. I myself did the same thing when following a tutorial early on. The problem comes when you start making a larger game and decide to implement a save system. If you've only learned player prefs, you're tempted to use it as a save system, which is not ideal at all. You can only save integers, floating point numbers, and strings. If your save system involves anything more than a high score, or maybe the player's name, you'll quickly start running into problems. And one glaring issue, your save file isn't an actual file in your hard drive. It doesn't take very long to learn how to write a proper save system, and it's a million times better than using player prefs, if only because you've learned something new. Of course, on occasion, you might find a clever solution that uses some system outside of its intended purpose, but it's not advisable to pull off hacks like that, and you should still look for a better method. And if nothing seems to fit your exact need, the right tool might just end up being something you make yourself. More than any other kind of programming, game dev is all about exceptions. Exceptions that as players might be hard to notice, but as a developer it can be very frustrating when even a simple new feature requires you to break a rule or rewrite some code. Take the building bonuses in Tetris City. Initially I had planned a simple system where each building gave the player a certain amount of coins or fuel each day, so I made a script that looped through all the buildings in the city and called a getBonus function. But then we decided to add the religious building, which doesn't give coins or fuel but increases the amount of buildings that spawn each day. This didn't fit neatly into the existing bonus system, so I knew we'd either have to rewrite a bunch of code or introduce an exception. In the end, we implemented some of the functionality through the bonus system, but we also added some extra logic in the building spawn AI script. And stories like this happen all the time. Want to add a few frames of jump buffering to your platformer to make it imperceptibly easier? Well, now you either get to redo your whole input system or add an exception. That's generally how it plays out. You either have to modify a larger system to add the feature you want, or handle it as a special case. Knowing which one to choose comes with lots of practice, and either way, there will always be trade-offs. Just like any other part of game development, the best way to get better at programming is just to make more games, and different types of games. Also, to be conscious about making your code readable and flexible. Learning about existing coding techniques always helps. A lot of methods for general software development apply to game dev as well. But try to avoid following any set of techniques religiously. If you want your code to be flexible, you have to be flexible as well. Finally, if you want to talk about game dev, coding, or anything else, join my Discord. Have a good day.